In this video, I'm going to go through a calculus question, and it's a paper 2 style question taken from IB Math Studies past papers, and this is November 2013. This is question 4 from that specific past paper. It's going to be quite a long video as I'm going to go through all the different parts. It's a 23 mark question, so I do expect you to spend 23 minutes on it. However, this video is going to be slightly longer because I'm going to spend time explaining some tiny steps. I am assuming you are capable of doing simple things like finding the definition of local maximum, local minimum, a bit of graphing, and understanding the gradient and rearranging. So there are certain steps that you should be aware of. I'm not going to go into the details of those. Do pause the video. Anything you don't understand, there's probably another video that I posted on it, especially the calculus section. There's a separate playlist for that. So we have a function, and they've given it to us as 3/4 x to the power 4 minus x to the power 3 minus 9x squared plus 20. And the first one is to find the value at -2, and this is simply just a substitution. So at -2, you have 3/4 -2 to the power 4 minus -2 cubed minus 9 -2 squared plus 20. Be careful of the negative and make sure that you put them in brackets. You don't forget these two negatives and these two negatives. And negative to the power of an odd number and negative to the power of an even number gives you different things. So just be aware of this. Make sure you just put brackets in the calculator. You get 1 mark for showing this method, just showing that you're substituting, and then giving the final answer, which will be 4. So quite a direct question, easy marks you could get. As for the second part, it asks you to find f of prime of x, which means just derive the function. So f of prime of x, I'm going to take the coefficient and multiply it, the power multiplied by the coefficient, so that's 4 times 3/4. And this will be x to the power of, we reduce the power, so it's going to be 3. And then minus, well, 3 is being multiplied by -1 here as the coefficient, so it's just going to be 3x to the power of 2. And then we have a -9 being multiplied by 2, the power, and x will be reduced to a power of 1. And the derivative of a coefficient is always 0. So I'm just going to simplify this. It's going to end up being 3x to the power of 3 minus 3x squared minus 18x. So that's the derivative. And it's a 3 mark question, meaning you're going to get 1 mark for every term you get correct. So 1 mark for this, 1 mark for that, 1 mark for the third. We got the 3 here, by the way, from canceling out the 4. So we end up with 3 here. So we get 1 mark for these. Obviously, this is going to be quite useful for the next parts of the parts that are going to come. So just be aware that parts C, D, and E all start with the same sentence, but this is just how I copied the question. This is not how it appears in the actual paper. But they all use the same fact that the graph of the function has a local minimum at x equals to -2, sorry. So that means that if I graph it at precisely x equals -2, this is a local minimum. Now, it wants you to use your answer in part B, meaning the derivative, to show that there's a second local minimum at x equals 3. So we know that our derivative is 3x cubed minus 3x squared minus 18x. And we know that at precisely f prime of 2, -2, the derivative is 0. Notice that at f of -2, it's 4, but at the derivative of -2, it's a local minimum. So we need to show that at f of -3, it is also 0. Okay, so we need to show this. And it's actually 2 things we need to show. One, we need to show that it's a stationary point. And the second thing you need to show is that it's a minimum, because it could be a maximum. It's a 5-mark question, so obviously there's more work involved than just substituting in. So the first 2 marks you're going to get will be from actually substituting in the 0. You go here and you say, well, if I substitute 3 in there, and I simplify it, so this is going to give you 81 minus 27 minus 54, and that's going to be a 0. And you go, well, good, so the derivative at x equals to 3 is 0, so we have a stationary point. We have a stationary point, but is it a minimum or is it a maximum? We need to prove that it's actually a minimum. So you could use several methods for proving that it's a minimum, including finding the second derivative, but I'm going to stick to the method that I've explained in a previous video. So we want to show it's a local minimum. So we want to end up with a negative gradient, a 0 gradient at 3, and then a positive gradient. So just recall that this is what we're trying to do. So you end up creating a value and f of prime table, and you're going to use 3 as your value. You want to test what happens before and after it. So we know that the derivative at 3 is 0. Now I initially tested the value at 0, but it gave me an answer of 0, so you don't want to go too far down. I would recommend you just use the next number, so 2 less than it, and then you want to go more. So this is less, and you can go more, and 4, because you're going to have your graph. So say we know that's going to be a local minimum. This is your 3. You want to test the numbers here, and you want to test the numbers here. So you want to test these x's and these x's, and you could pick any value, but it's better to just stick close. So at f of prime of 2, we can just substitute. So you have 2 cubed minus 32 squared minus 18, 2. So this is going to be 24 minus 12 minus 36, and that's going to be a negative 24. So this is a negative 24. So the point here is that it's a negative gradient. So the tangent at this point will have a negative gradient. So this is how it's going to be. You have a gradient of 0 here. So, and then we substitute 4 just for sake of checking. You have 3 to the power of 4 raised to the power of 3 minus 3 and then 4 squared. And then we have minus 18 bracket 4. And this is going to give you, it should give you a positive answer. Great, so this is going to be, sorry for the delay, it's going to be 72. So so it's a positive gradient. So we knew it was going to be a positive gradient. There was couple of issues with the calculator giving me big numbers. So we have 72 here, and we know it's going to be a local minimum. So this is an explanation you could use. So since the gradient goes from, could say since the gradient goes from negative to 0 to positive, then it's a local minimum. Okay, so that's you getting the 5 mark. For part D, you are expected to sketch, and I've noticed that a lot of the past paper questions regarding calculus use this step. So you need to sketch the function where x is between -5 and 5 and y is between -4 and 50. Indicate on your sketch the coordinates of the y-intercept. So this is quite important to point out. So if we go, and you will be given graph paper to use, but let's say we have, let's say this was your, so they want between -5 and 5, so this is your -5, this is your 5, and let's say this was your -40, and they wanted up to 50. Now you could always use your calculator to sketch this, and you could always put the window where the minimum for x is -5, maximum is 5, and similarly for y, the minimum would be -40 and the maximum would be 50. And you'd be able to see what kind of sketch you're expected to do. So you get 1 mark for actually labeling the axes. So this will be your x-axis, this will be your y-axis. It's a 4-mark question, so there are many steps you need to consider. Then the main thing about graphs is the changes that occur in a graph. So these give you an indicator of what you should do. And the changes are usually your stationary points. So these are your biggest clues. So the first stationary point, well, we know is at -2. And the y value at -2 is actually 4, and we found this here. So this, we just substitute -2 in the original, that's how you'd find the y value. So we know that the first minimum, local minimum, occurs at -2 and then 4, so somewhere here, quite low. So let's say this is our local minimum. And it's a local minimum, so remember the gradient goes this, and then up, so the curve is going to be like this. So obviously it's going to go up somewhere now. Let's graph our second stationary point. So our second stationary point was at 3. And then we need to know the y value at 3. So we need to go, well, what is the y value at 3? So you need to substitute 3 in your original equation. And if we substitute that in, you should get, you could either substitute 3 or just indicate that you know where it should be. But showing these steps would be quite important as well, just so that you don't mix up the steps. So we substitute 3 into the formula. You can skip ahead until I actually find the answer. So 3 in there. Remember to go to the original, so you get a -27.25. So it's going to be halfway here, since this is -40, so halfway here about. And then we're at 3, so somewhere here. Okay, so this could be our local minimum. So this is our 3, this is our -2. Actually, that's too low. Let's go there. So this could be our local minimum again. So there's a dip here, which means there's a maximum that goes somewhere here. So there's something, it could be here, it could be somewhere else, but as long as there's a maximum involved, because there's no way you'd get a minimum and a minimum only. So, well, regardless of the maximum, they actually wanted the y-intercept. And the y-intercept is found by substituting f of 0. So you need to know what is the value of y when f is actually equal to 0. And you can actually try it on your own in the original if I substitute, again, f of 0, it's going to give you a 20. So right about here, that's a 20. So you clearly show that this is where they meet, and then you have your dip. Obviously, you can't stop here. You need to go up to 5, because that's how far your graph has to show. So this is a rough sketch. You get 1 mark for a smooth curve with the correct shape. You get 1 mark for showing the minimum. So in the second quadrant and the fourth quadrant, you get 1 mark for the y-intercept. So these are the 4 marks. So again, 1 mark for labeling the scales and indication of the scale. So the -5 to 5, the -40 to 50. The smoothness, the local minimum, and the y-intercept. So these are all quite important. So we've done part D. Part E, again using this fact that x is equal to -2, write down the coordinates of the local maximum. So back to your graph, obviously the local maximum will be somewhere here. And there is a reason why they wanted the graph first, and there might be a reason why they wanted the y-intercept, because, well, maybe 0 is the local maximum. So I'm going to show you 2 methods for this. You could test it immediately. You can either go, you could immediately substitute in the derivative. You could substitute 0 in there, so 0 cubed minus 3, 0 squared minus 18, 0. And you'd notice that they all give you a 0, so it ends up with 0. And the derivative at that is 0, which means it's a local maximum. And you could do the testing if you want, but it's a 2-mark question, so they're not expecting you to do that. They do want the coordinates though, so the local maximum is at x equals to 0. And at x equals 0, y is actually equal to 20. So the coordinate of the local maximum is 0, 20. Another way, just to be clear as to why we're getting 3 stationary points, 1, 2, 3, is because this is a cubic, the derivative. This is a side note. If you're not interested, you can skip ahead. The derivative is 3x cubed minus 3x squared minus 18x. This is a cubic function, and most cubic functions have 3 roots or 3 solutions at maximum. So we do expect whenever we're solving these to get 3 solutions. So we can factor an x out. So I can take 1 x from all of them because they all share 1. This would not have been possible if there was an extra, say, 3 in there. So that wouldn't have been possible. So I'm just going to factor 3 out. I can actually factor 3x out from there. So you end up with x squared minus x minus 6 in here. And we can say that this is equal to 0. Because this is what you're trying to find. You're trying to find what values in the derivative will give you a 0. And this is actually, you're trying to solve a cubic equation. So when you are given this situation, we always say that either this gives you a 0 or this gives you a 0. So you're faced with either 3x is equal to 0 or x squared minus x minus 6 is equal to 0. And the solution to this is, well, you divide 3 on both sides and end up with x equals to 0. So that's one solution, which is the solution we found here. And then for this, this can be factorized into, you could use a quadratic equation as well. This could be factorized into x minus 3 and x plus 2 equals to 0. And so your solutions are x equals to 3 and x equals to -2, which are the 2 other local minimum and maximum. So these are your solutions to the derivative function. I'm not talking about the original. So just to be aware of this side note, that's why we know there are 3 solutions, and that's why x equals to 0 is one of the solutions. So up to the 2 parts, so usually they follow up with the tangent. Let t be the tangent to the graph at the point 2, negative 12. So find the gradient of t. So we have our graph, our lovely graph here. So at x equals to 2, there's a tangent somewhere. It could be here, for example, and there's a straight tangent, and we need to know the gradients of this tangent. So you should immediately think, well, if I want the gradient, I'll just use the derivative function. So you need to use that. And you want to know the gradients at this point, so it's just going to be you substituting 2 in there. So just immediately do the substitution. You need to show it, and that's going to give you a negative 24. You actually need to show the solution, so the substitution. So you have cube minus a2 squared minus 18(2). That's a negative 24. Now, the line L passes through the same point and is perpendicular to t. So this is your keyword. So when you have, we had the graph, we had this. So the tangent was in such a way, though this was our t, the line L was perpendicular to it. So it was 90 degrees there. L has an equation of this form, so this is a way of writing an equation where b and c are actual integers. Find the gradient of L and the value of b and c. So the gradient of a perpendicular is always the negative reciprocal. And the negative reciprocal just means change the sign. So if it was a positive, it becomes a negative. If it was a negative, it becomes a positive. So the gradient of the tangent at 2 was negative 24, which means the gradient of the perpendicular will be changing the sign, so it's going to be positive, and then flipping this fraction. So this is a 24 over 1. So you flip it and it's going to be 24. So this is the reciprocal. So the gradient is actually 1 over 24. Now to find the value of b and c, it's just basically you're trying to find the equation, you're going to rearrange it, and then whatever you get for b and c will be your answers. So it's not something magical you'll have to do. It's basically just write the equation of the line. I'm going to go through 2 methods, and that will be the end of this really long video. So the first method to actually is to go, well, you have y equals mx plus c. You can use this method. We have the gradient, and that is 1 over 24 x plus c. We need to find the c, and the c I'm referring to is not the c, so it's not the same thing. This is just the y-intercept c. So again, be aware this c is a different one. It's just the y-intercept c. So and in this case, in order to find this y-intercept, I need to substitute a value of y and x that I know. Well, I'm considering this point, and I know this point lies on this line, so I'm just going to substitute it in there. So you have a negative 12 for y, 1 over 24, and this will be a 2 plus c. And so this simplifies to 1 over 12 plus c. And then I could take this 1 over 12 to the other side. It's going to be a minus, so negative 12 minus 1 over 12 equals to c. And so c is equal to this will be a negative 145 over 12. So the equation right now is y equals to 1 over 24x minus 145 over 12. But we need to rearrange it to this form. I'll just rewrite it here. So our final one is y equals to minus 145 over 12. I'm just going to go through the second method, which is what the past papers usually refer to, and that is to use a specific formula. The reason I usually avoid it in class is because it requires memorization. The formula is you taking y and then minus y1, whatever your coordinates is, equals to your gradients and then x minus x1. So y1 and x1 refer to your gradients, your coordinates, sorry. So you have y minus negative 12 is equal to, the gradients was 24, x minus, and then it was 2. So we simplify this, y plus 12 is equal to 1 over 24 x, I'm just multiplying out of the bracket, and then the 1 over 24 times negative 2 will simplify to negative 1 over 12. And then I can move the positive 12 to the other side just to simplify it, and you end up with minus 1 over 12 minus 12, and that will give us the same results, minus 145 over 12. So we end up with the same thing, but now we need to rearrange it. And we need to move everything to one side and make get all the numbers and letters on one side and then have 0 on the other side. So notice that you have x is positive here, which means I need to, it would be better if we move the y to the other side. So we end up with 0 is equal to 1 over 24x minus y minus 145 over 12. Well, this is not nice. Again, they told us that it has to be x plus b, y plus c equals to 0. Now, b and y could be negative numbers, it's fine, but as long as x has a power of 1. So then we're facing the issue of quite a complicated simplification situation. This is what we want to get to, so a bit of this, but we are dealing with the fractions here that are a bit annoying, so we can actually solve them a bit ahead. So if we get both numbers in one denominator, that would be great. So that's always the tip to cancelling out, to simplifying this fraction into the general form, because this is the y mx plus c form. So you get 1 over 24 x, and then you're going to multiply this fraction by 2 because it's going to change the denominator to 24. So you end up with negative 290 over 24. And I can simplify this into one fraction. So I have x minus 290 over 24. Well, this is nice because now I can actually cross multiply. So I can cross multiply, and you get 24 times y is equal to x minus 290. Well, now it's good because I don't have fraction. I don't have a fraction, and the coefficient of x is 1. So again, as I mentioned, because x is positive, let's keep it here, and let's just move the y to the other side. So because we moved y, we end up with 0 on this side, and we have x minus 24y minus 290. You can write the y in the end. I'm just rearranging it nicely this way. So now we actually have the form of, they told us it's x plus b, y plus c equals to 0. Doesn't matter how we've written it, as long as it's 0 on one side and x is positive and then everything else, which means b is the coefficient of y, and that is negative 24, and c is the coefficient of, c is just the constant here, so that's negative 290. I know this was a long question. Hopefully it was useful. Quite in detail, a lot of things you need to remember, but this is typically how calculus questions are laid out for paper 2. And I'm gonna stop there in 30 minutes, so